Hello, and welcome to the last video of this section, Reinventing Your GUI. In the previous video, we've learned how to use FireMonkey in a VCL application. In this video, we'll learn how to reinvent your GUI. As you have surely understood at this point, FireMonkey is a completely new graphic library which allows a completely new way to think about your GUI. You must realize as soon as possible that FireMonkey is not a cross-platform VCL. It is a new beast with new possibilities and new things to know. So you have to rethink your GUI architecture because many patterns used in the last 5, 10, 15 or more years of VCL development now may be simply obsolete or are no more the best things to do. For instance, you have to display a pie chart with some user interaction and some nice visual effects. When the user moves the mouse over a pie slice, the slice gets highlighted and some information is shown to the user. How can you achieve that? In VCL, there are two ways. Write your own code, a lot of, or use a third-party control. In FireMonkey, there's also a third way. Use the primitive shapes to create it using no third-party controls and a very limited amount of code. This is a recurring pattern in FireMonkey. This is the reason because probably your FireMonkey application needs a lot fewer third-party controls than the VCL one. To show you how this is possible, in this video, we'll create a simple pie chart with such aspect and user behavior. Here's an image of an application we'll build. The first steps to design your GUI is to slow down and think about it. We need a pie chart, isn't it? So, is there a primitive shape package as component in the FireMonkey library able to draw a slice of pie? Yes, there is the tPie control, but we need a variable number of slices, and all the slices must be stacked one over the other to make a full pie. Where could we put these dynamically created slices? Obviously in a T layout. This is the basic idea behind the video. Let's talk about the code in detail. Open the project named piechart.dproj. The main form is quite simple. There is a T-string grid to allow the user to write the data, a T button which actually starts the regeneration of the chart, another button to add a new row in the grid, a T label to show some additional information when the user moves the mouse over the single slice, and the T layout we already talked about. Here's the main form at design time. In the form create event handler, the initialization code creates the tDictionary open bracket string extended close bracket, which will contain the data represented in the chart. Moreover, considering this is a sample, the data is generated randomly and used to fill the grid. Here's the form create code. As you can see, the generated data is about some companies so that each row in the grid will contain the company name and units sold of something. Now interesting things happen under the Refresh Pie Chart button. Here's the code. Loads the data from the string grid and put them in the dictionary using the company name for the key and the units sold as the value. Now, this line of code get the total for all the companies using a higher order function. This will remove all the tPie already present in the T layout. The first time there aren't child, but from the second time, yes. So let's remove all the tPie from the T layout, lytpie.delete children. This will loop through the dictionary and create each tPie. This line will show some math to know how many degree each pie slide must be. This line will build the pie slice. Check the build pie slice for details. This will set up some nice gradients color to give a sort of fake 3D effect to each slice. So let's give some dynamicity to the chart with some effects using this line of code. There's quite a lot of stuff in this method. Let's analyze the interesting parts of it. After having loaded the data into the dictionary, we're using a higher order function to summarize the total for the units sold by all the companies. This function is a part of the Fun with Anonymous methods using higher order functions of Section 2. It is a reduce function, which is used here to do a sum, so that the result of the function is the total of all the units sold. Having the total, we can start with the loop to create each tPie and add it into the T layout. Each tPie starts its slice where the previous one ends, so that the nth slice has its start angle equal to the end angle of the previous slice. Here's the code for the build pie slice method and the other methods used by it. This line of code will create the pie as child of T-layout. This will set up some events to give interactivity. We need the company name to which each pie is referred to. We have used this line. This line of code will align to the parent so that all the T-pie are aligned and stacked one over the other. This line of code moved the current T-pie to the front so that the effects applied effect are not covered by the other T-pie. This will get the value for the company, which the pie refers to, and calculate the percentage over the total. This line of code will display the data in the T-label. This will clear the T-label when the mouse leaves the T-pie. The color of each T-pie is provided by a function contained in the colors_utils.pas unit. This unit contains a static array of colors and some functions to manipulate them. Here's the code. This will get a color from the list. This line of code will return a color which is a percentage darker than the input. This will return a color which is a percentage lighter than the input. Nothing complex here, but the RTL interpolate color function is quite interesting. This function is used by the T-color animation effect and other classes, and has this prototype. The function interpolates color value between colors start and stop at time moment t. So when t equals 0, the result is equal to start, and when t equals 1, the result is equal to stop. Interesting. But we need a function that is able to create a lighter or a darker color starting from one given color. How can we use the interpolate color to do that? Quite simple. What is the darkest color in the world? Black, which, as you know, strictly speaking, is not even a color. So if I need to create a color which is 20% darker than standard red, I can use interpolate color to create a new color that tends to be dark, but it is only at 20% of the transition. The code looks like the following. We use the same approach to create a lighter color. What's the lightest color in the world? White. So the code here is simple and effective. There are two more interesting methods to explain in the main form. The first one is setup gradient. Given a T-brush and a reference color, this method sets up the brush to use the color gradient, which starts from the reference color and ends at a color 50% darker. And the code for that is selected here. The last method is inject FX, which adds effects and animations to the TFMX object passed in. These effects are triggered when the mouse moves over the control and are an inner glow, a color animation of the stroke from black to a reference color, a size animation of the stroke thickness to make the border more evident. Here's the code which inject the effect to the TFMX object passed in. With some code and a bit of cleverness, we've created a not-so-bad pie chart using only the basic FireMonkey shapes, effects, and animation. The same concepts can be used in other situations. For instance, now that we know how to create this pie chart, how difficult could it be to create a histogram? Very simple. You have to use the T-rectangle instead of the T-pie, and linear distance instead of degrees. Yes, FireMonkey is very flexible and really pays back the time spent to get confident with it. Now, launch the program. Click on the Refresh Pie Chart button and see the chart. Move the mouse over the slices and see how the behaviors implemented make the GUI nice to see. You can also add a new row in the grid, put other data, and hit the Refresh Pie Chart button once more to see how it changes. In this video, we spoke about the basic T layout. However, there are a lot of layouts. Here's a link to understand the basics about them. It's quite important to know all the layouts available in FireMonkey. As the Embarcadero documentation says, FireMonkey layouts are containers for other graphical objects that can be used to build complex interfaces with visual appeal. The FireMonkey layouts extend the functionality of T-Control to control the arrangement, sizing, and scaling of their child controls, and offer the possibility to manipulate a group of controls as a whole. The way you arrange controls inside the layouts is also important. This link can help you get in touch with the basics of FireMonkey. Great! We've successfully reinvented your GUI. This video concludes the last video of this section.